So this is a brief overview of cardiac output and its regulations, and we're going to go over some of the parameters that affect cardiac output. This presentation is given to you by Kalyn, Baisley, Bevell, Joel Olmstead, and Allyson Price. So first we're going to give a brief overview of the cardiac system and the cardiac cycle. The heart pumps blood through a closed system of vessels. This blood then supplies systemic organs, and this is all arranged in a parallel circuit. Valves in the heart and veins ensure that blood flows in only one direction. The function of this system is to transport nutrients, water, gases, waste, and chemicals throughout our body. Systole is a period of contraction and is a time of emptying, while diastole is a period of relaxation and filling. The cardiac cycle is an overall cycle that includes around 6 steps, and it lasts approximately 0.8 seconds. So first step is early diastole, where you have the semilunar valves closed and isovolumetric contraction. In the second step, we have mid-diastole, where the AV, the atrioventricular valves, are open and you have passive inflow. The pause is called diastasis, and on step 4 we have atriosystole, which is where the atrial contract, causing active flow from the atria to the ventricles, and this is also called the atrial kick. Next we have early ventricular systole, where the atrioventricular valves close and you have a period of isovolumetric contraction. This is the period before the pressure rises too much in ventricular systole and before you have the semilunar valves open. So next we have the actual time where the pressure increases in the ventricles, and you finally have the explosive opening of the semilunar valves and active flow from pulmonary vessels and from the ventricles to the pulmonary vessels and aortic trunk. So this whole presentation is about cardiac output. So what is cardiac output? It is the blood flow that delivers nutrients required by every cell and removes waste products of cellular metabolism. So we kind of have a function that was given to us in class, and it's called cardiac output equals heart rate times stroke volume, which are the two parameters we'll be discussing in more length. But cardiac output at rest equals about 5 liters per minute. So why might cardiac output be important? It's important because it's one of the parameters in the regulation of the mean arterial pressure, which is part of our blood pressure. The other parameter is total peripheral resistance, which we won't go into discussion about in this presentation. So here's a little diagram that we found that kind of outlines all the parameters that go into cardiac output, and we are going to be emphasizing heart rate and stroke volume and some of the things that affect those two parameters. But this is a good diagram to go back and look at. Next we'll have Jared speaking over heart rate, and finally Joel speaking over stroke volume.
Okay, heart rate is the number of times the heart beats per minute. At rest, the normal heart rate is between 60 and 100 beats. This rate is determined by the sympathetic nervous system, which has a positive conotropic effect, or tachycardia. This can be affected by the release of hormones from the adrenal medulla. And then next we have the parasympathetic nervous system, which has a negative conotropic effect on or bradycardia. Quickly, I just want to talk about a couple of conditions that can cause either a positive conotropic effect or a negative. The first of which is a person can take substances such as coffee and tea. This will inhibit the breakdown of CAMP, which is cyclic adenosine monophosphate. It activates an enzyme that phosphorylates calcium channels in the plasma membrane. This phosphorylation increases calcium to flow into the monocyte, causing the heart to beat to increase. So if this is blocked, obviously that effect will continue. Another positive conotropic effect is hyperthyroidism, which is caused by an increase in thyroid hormone thyroxine. And this also causes the heart to be more responsive to the central nervous system and increase heart rate. A condition that has a negative conotropic effect is hyperkalemia. This is where there's an abundance of potassium, which is diffusing into the heart cells, making the membrane potential less negative, and as a result, the myocardium becomes less excitable, heart rate slows down, and may even arrest in diastole. Next we'll have Joel.
Alright, I'll be talking about stroke volume. Stroke volume is the quantity of blood pumped out of ventricles per beat. At rest, this is generally about 70 milliliters per beat. Stroke volume can be determined by finding the difference between end diastolic ventricular volume and end systolic ventricular volume, or the blood between the blood in the ventricle prior to contraction minus the blood in the ventricle after contraction. Stroke volume is affected by a few factors. Firstly, preload has a positive effect on stroke volume. It's the load or stretch on the ventricles before they contract. It's directly influenced by the end diastolic volume, which is the quantity of blood in either ventricle at the end of diastole. Frank's Starling law confirms the effects of preload. It states that the more the ventricles are filled during diastole, the more blood they will eject during systole. Greater preload will equal greater force of contraction. Cardiac contractility has a variable effect on stroke volume. It's the intrinsic or internal ability of the heart to contract. It's based on the amount of binding between actin and myosin filaments and the amount of calcium ions present within the muscle cells of the heart. The sympathetic nervous system will have a positive inotropic effect on the cardiac contractility. It does this by sending epinephrine and norepinephrine into the muscle cells, causing them to contract harder. Afterload has a negative effect on stroke volume. It's the pressure that the ventricles of the heart must work against in order to eject blood. It's called the aortic pressure on the left ventricle and the pulmonic pressure on the right ventricle. The pressures in the ventricles must be greater than the systemic or pulmonary pressure in order to open the valves of the heart and move blood out. Higher afterload will result in a lower stroke volume. And next we have a diagram kind of outlining what we've been discussing as far as how heart rate and stroke volume affect cardiac output, and then some of the parameters that affect each, the stroke volume and the heart rate. And next we have a video that discusses.
Today we're going to talk about a very important component of cardiac physiology, the cardiac output. And cardiac output is the amount of blood that the heart pumps to the rest of the body per unit of time. And it's dependent on two important variables. The first variable is the stroke volume. And the stroke volume is the amount of blood that is pumped per beat of the heart. The second variable is the heart rate. So the cardiac output is basically the stroke volume times the heart rate, which gives us a volume of blood pumped per unit of time to the rest of the body. Now, let's talk a little bit more in depth about the stroke volume. The stroke volume is dependent on a couple of key and important topics. The first topic, contractility. So you can imagine if the heart is contracting with more force, it's going to be able to pump more blood per beat, increasing the stroke volume, which will increase the cardiac output. The second key component of stroke volume is what is known as preload. And preload you can think of as the amount of blood that's sitting in the heart right before it contracts. Another way of thinking about preload is basically the end diastolic volume, or when the heart relaxes, how much blood flows into the ventricle to be pumped out. So if preload increases, there's more blood ready to be pumped out to the rest of the body. Stroke volume will increase and cardiac output will increase. The third component is what's known as afterload. And afterload is the pressure the heart must overcome to eject that blood into the rest of the body. And this is basically the mean arterial pressure, which is a component of the blood pressure. So these are the key and important elements of the cardiac output. And in future videos, we'll talk a little bit about why the cardiac output is such an important physiological topic to discuss when talking about different diseases of the heart and vasculature. Thank you.
So here are references for our Prezi, and thank you so much for watching. Hope this has helped in your understanding of cardiac output.